There is a massive gap between it works on my local host and it works at enterprise scale. If you look at most tutorials about AI, they teach you how to develop an AI wrapper. Wrappers are tall boots. They take a file, they send it to a public API, and they hope for the best. That works for a demo. However, if you try to deploy this in a production environment, you are going to hit two walls that a simple API wrapper cannot solve. 1. The trust gap. You cannot pipe sensitive legal or financial documents to a public API. Your files and data must stay at your VPC. 2. The blocking problem. If you try to pass a 500-page manual on your main thread, your application is going to freeze and it will become unusable for all your other users. To solve this, we need to stop scripting and start engineering cognitive architectures. Today, in the first video of building, breaking, and documenting, I'm going to show you how I engineered a sovereign event-driven memory layer. I designed SmartDocs to work and function as a high-frequency trading desk. Imagine a trader on Wall Street. You don't want them stopping to file paperwork. You want them to trade and earn money. The wrapper's way makes the trader stop to file each document manually. The market moves, the server hangs, and you lose money. The SmartDocs way is different. The trader hits a button, a request is queued instantly, and a dedicated office worker starts processing the file asynchronously. The trading never stops. In our stack, it looks like this. The trader is NestJS. It accepts a file, writes a pending state to Postgres, and returns an optimistic response in a matter of milliseconds. The queue is Redis. It decouples ingestion, it handles backpressure, and retries automatically. The back office is the worker. It's an isolated microservice that wakes up to parse the document and then securely commits the parsed data to the PG vector database. Now let's look at the actual code that enforces our sovereign ingestion. I have moved the core logic into the ingestion service. Notice right here, we are not trusting the PDF file. We are making sure by inspecting the magic bytes that the file is valid and is okay to be processed. We take a 5-byte subarray of the buffer and verify the hex signature. If it doesn't match the standard PDF header, we throw an error immediately. We don't waste a single CPU cycle on corrupted or malicious data. In the processor, we handle the state machine. Before we even start processing, we make sure that the status of the document is set to processing in the Prisma database. This gives the front-end real-time telemetry. If the worker crashes or the PDF is invalid, our catch block ensures that the database reflects a failed state with a specific error message. Now let's try to execute a file upload curl command through CLI and see what happens. I've already typed a curl request, as you can see in the CLI. Let's hit enter. Notice that the Nest server is running successfully, and I can also show you my Docker container which has the Redis and the SmartDocs database. So let's hit enter. You instantly get a status which is queued and a job ID. Not only that, you instantly see on the left side of the screen that the worker has started to work on job 32, which is the job that we see here. It has successfully received the buffer size. It then parsed the PDF with this as its length, and it extracted the text from the doc. As you can see, this is the first line of the document. Once the text has been extracted, the worker marks the job as complete, and the information is safely stored in the PG vector database. As you can see now in the Prisma Studio, if you go to the document table, you will see the file and it has all the text in it, as you can see, and there should be a timestamp here as well. As you can see the timestamp here. So the job was completed. This isn't just a wrapper, it's a fault-tolerant ingestion engine. Phase 4 is complete. We have successfully built the memory layer. In the next video, we are going to build the brain of the system by connecting our storage with LangChain and reasoning with it. Stop building wrappers. I'll see you in the next build.